Let's start lecture. Get your clickers ready. We're going to do some clicking in just a minute. And actually, I'm going to show you a practice problem for the exam. Let's talk about, let's go back here. I want to make a mention right now before we run out of time. There's going to be our first assignment in the Great Rivers Learning website for our textbook. And I'll kind of show you how to get into it. And that's going to be due as one of several study assignments next Tuesday. It's going to activate at noon today, and then it'll be available all the way up to the beginning of your exam. So anyways, let's talk about exam one. I know everybody's always kind of nervous about exam one. It's next Tuesday. So when you come in on Tuesday next week, be ready for bear, be loaded for bear, be on time, and be ready to get a seat, chop. Because the less time I spend organizing you guys to sit, where I want, the more time you have for the exam. So, and it's an hour exam. So 50 minutes, 50 points. And that usually is 50 Scantron questions. That's pretty good for an hour. I usually go one multiple choice question per minute. So 50 minutes for 50 Scantron questions, and then I round it off to a full hour. Now you probably have a little bit more than that if you can get in here and if we can get started fast. Okay, so that's what you want. So you might have 64 minutes if everybody is organized and not messed up. But the thing is, you're going to want to bring your iClicker, and the iClicker is going to be 2 or 3 questions, the very last 2 or 3 questions, depending on how I write the exam. And those will be calculations. Like I might ask you to calculate a drop distance or maybe something trickier. And you'll type in the numbers like we've been doing in class, and we're going to do some today. And you'll be able to do that at your own pace. And I'll start this session, the clicker session, at the beginning of the test. And for that reason, we might have 3 clicker questions and a total of 5 points, 2 2-pointers and a 1-point. Sometimes I throw a multiple choice question in with the clicker. So you might have 5 clicker points, and that means you're going to have 45 Scantron questions because those are always 1 point each. Okay. So between the two, Scantron, so you're going to fill up most of the front of the Scantron. And then you're going to have, so you might only have like 47 questions or 45 questions. And then you're going to do the rest of it with your iClicker. So you make sure you bring your iClicker. Okay. Now, as to, everybody's always asking me, Dr. B, are you going to make a study guide? No. I never make a study guide. You guys have the study guide. I want you to think of your lecture notes as your study guide. All right, so the chapter coverage is going to be from the introduction all the way up to as far in chapter 3 as we get on Thursday. Now, we're probably not going to get all the way through chapter 3. We might get to chapter 3, section 6, or who knows. We'll try to get a start on chapter 3 today. And then read, so as far as we get. Now, as I understand, there was some missing sections. I look, not as I understand, as I know, there were some missing sections for chapter 3. They put in the new stuff from chapter 3.8 to the end of the new end of the chapter, and they forgot the previous edition, the second edition material, which is 3.1 through 3.7. So, but they're going to put that back in today, so you should be able to read all that stuff. Anyways, always think of your lecture notes as your study guide, because, you know, the expectation is that, oh, the instructor gives you a study guide, so now I know what's really important for the exam. But you already know that, because in lecture, I'm not going to talk about something that's peripheral, because they could make a million. We could spend a week on we could spend a semester on Galileo. You know, we could spend a semester on Newton's second law of motion. So every day I have to decide, of the 1,000,001 things that I could talk about, you know, the 4 or 5 that I will talk about. And that means that's the stuff I consider important. So always think about that when you're going over your notes. Use YouTube to review and improve your notes. You know, sharpen them up, and, ooh, I missed that. Put that in, you know, and add that. And it, my TA that's not with us this semester, Darian Fry, she is the mistress of crushing exams. When she was a student in this class, and that's one of the things that she did every lecture. She went and looked at YouTube and restudied her notes and improved them and stuff. So it's a good study technique. So the lecture notes are primary importance. Remember that. That's the center of all my thinking and all my communication is lecture. Now, secondary importance, homework items. All right? You know, that's fair game. Clicker items. Yeah. All right. And then readings in the website, the Great River Learning website, the chapter that support or amplify the lecture. So if you see something in lecture and then you're reading through the book and it's, hey, he was talking about that in lecture, make sure to review that paragraph. Okay? So that's support. All right? So I don't always get to talk about everything, every single object, every single sentence in the textbook. But if you do find something that's related to what I talk about in lecture, consider that to be, you know, a secondary level compared to the lecture. All right. Now, any questions about that? Okay, let's keep going. There's going to be an SI review. Now, I know some of you cannot make the regular SI. This is a hour and a half SI review to prepare for the exam. And this is in addition to the other Monday sessions, I think. So Maria is going to have that at Nicholson. Room 108, 3:30 to 5 p.m. on Monday next week. So she'll trot you through, you know, I mean, she knows my wily tricks on exam. You guys don't, but she does. And she'll be able to give you some wise advice. So as I've mentioned before, for regular SI sessions, if you cannot make the entire session, go to the time that you can make. So if you can't get there until 4 o'clock, just go. You know, she's not taking attendance. You know, it's not like you're not allowed after 3:30 or anything. Now, exams, you got to be on time on exam day. And here's, you know, I think I told you about it before, but my rule is this. If you're late a couple minutes, you'll come down to the front and take, you know, we'll save a seat for you down here and we'll get you a test. But if you're so late that the first person has turned in their exam and left the room, that's it. You can't take the test. All right? So the first person, and that's on a test of my making, an hour test, the first person usually finishes in about 20 minutes. Okay, so, you know, and they're not always the top score either, but that's what they do. And they go in there, and they're not Christmas treeing the test, but, they just work fast and, see what sometimes they have a good grade, sometimes they have a medium grade. But anyways, 20 minutes. So, but the thing is, so what you want to shoot for, just be here at 9. Be here at 8:59. By the way, I'll make another mention to you. Nobody is in here until you guys. So if you get here early on a Tuesday or a Thursday, just blaze in here. And, if you have a friend that you've made in class, then it's a good time for study, right before lecture. Okay? And that's my admonition to everyone. If you haven't made a friend yet, try to make a friend in this class or the other section, and as a study partner. It really helps. That's the main thing that I can advise you on. Anyway, so SI review Monday. Make it if you can. If you can't, you can't. But try to make it even for 15, 20 minutes. It'll definitely benefit you. All right, now what to bring for the exam. First of all, you want to bring a UCF raspberry colored Scantron, the one with 50 questions on the front, and it has 50 on the back. And we'll use the back on the final, but for the midterms, just the front. It has the UCF Pegasus logo on it. Now, if you're in the School of Business, they use a completely different Scantron. I think it's brown colored and it's not as big. So don't bring it if you want, but you can't use it. All right, you got to use the raspberry flavored, or the raspberry colored ones. All right, bring yourself a good pencil. This is the kind I use. Matter of fact, I think I got one right here. Okay? This is the ticket. I don't like those mechanical pencils on Scantron questions, Scantron tests. Bring a good eraser. Now, one of these fourth grade erasers for when you're a little shrimpy kid, they're actually the best. Because, and here's why I don't like the mechanical pencils and the cheap wooden pencils. The erasers sometimes, you decide, I didn't want to bubble in A, I want it to bubble in C. All right, that's good, but if you have a stinky pencil, it'll wear a hole in the Scantron. Whoops, that's no good. So get one of these rectangular, and sometimes even a good pencil has a good eraser, good enough. But do that. Also, calculator. This is a TI-30X, and it's a solar one. But anyways, bring one of those. If it has a square root key, you're good. And the other thing is, bring your eye clicker. All right. So, and I'll mention this again on Thursday, but this is the basic equipment. Now, here's what you may have on your person, but you may not use during the test. A cell phone. You must have that put away. All right? And every semester I see a student, that's using, we see him. And you know what? We had some cheating in this class over the summer. And I just got notice of, they had the hearing and everything. And it was pretty grievous, the punishment that they got. Now, if you're using a cell phone in a test, we're going to assume you're cheating, right? So you may not use it for any reason. Just put that out of your mind. All right. You can use it before the test and after the test, but not during the test. All right, any question about materials to bring? Yes, Connor.
Where do you get the Raspberry Scantron?
The Raspberry Scantrons, you can get them at the bookstore. There's vending machines around. You can get a packet of 6, I think. And for how much is a vending? Is that like $1? $1 for a package? But then the student union, you go up to the student government, the SGA office, and you can get one free one per day up there. So go up there, after class, nab one, and ding, you're ready. But they have packets of 6, and that'll fix you up for my class, and you have 2 extras. So another question. Morning. Okay, let's keep going. Another thing that students worry about, and nobody's actually asked me about it yet, but I know it's on your minds, and that is, Dr. B, do we get a formula sheet or something like that? And the answer to that is no. What I normally do is I give you a few matching items at the first 3 or 4 questions, and so there's like a formula over here, an equation, and then a concept over here, or a list of 4 concepts, and you have to match them. Okay, so it's equivalent to having an equation sheet, but you get points for it. But you don't have to memorize. All you have to do is recognize. Now we're going to do an example of that in just a second, as soon as this kid's finished crushing physics. So here's what it looks like, and we're going to do clicking with this in a minute. So over there on the left are 3 concepts: definition of acceleration, Newton's second law, and Galileo's new state of motion. Now, we've talked about all those except for number 2. Number 2 we're going to talk about today. So I'll give you the answer for that one when we get to it. But then over on the right side, you have letters A, B, C, and D. And so you got to say, all right, now which one of these is definition of acceleration? Which one's Newton's second law, et cetera, et cetera. All right, and then you fill that in on your Scantron. And so then you've got the equivalent of a formula sheet, and I'll have as many matching items as you need so that you have all the equations that you'll need. All right? Except sometimes I'll put a formula directly in the question if I feel like being nice. All right, so other than that, you'll have it all in your matching section. So here we go. Let's do some matching and this is multiple choice, so go ahead and turn on your clicker. If you haven't used it yet, this is your first time. Hold the power button until the rectangle flashes in the upper left, and then type in DD for delta delta. All right? And here's your first matching question. Number 1, definition of acceleration. Go ahead and vote. Okay. And I know you guys are doing a good job with your voting. It says closed. Try it again. Hit refresh. I got people voting, so hit refresh. See if you get it back. Anybody have a no base? Okay, hurry up. We're clicking. Okay. All right, 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, 99 people voted. Let me see what you guys voted for. Well, you guys are geniuses. Yeah. C is the correct answer for that one. Okay, so you might see something like that on the, or I might put it the other way around, the equations on the left and the concepts A, B, C, D, and E, but it'll be some variation of this. All right, let's do another one. Newton's second law. Okay, this one, if you don't know the answer to this, actually, it's not D. So use your mind to eliminate two others, and you should be able to do that because you know what you definitely know what C is. So C's out, D is out. All right, and so okay, 15 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, most of you got that one right. It's A. And here's how you know it's not C because that was the previous answer. All right? And I told you that it's not D. So is it B or is it A? Well, B is a position equation for free fall. So that's not one of Newton's that's not one of Newton's laws. So that means by process of elimination. And remember to use that on the exam. If you get stumped, sometimes you can make an educated guess, eliminate one or two and then make an educated guess, and that'll increase the probability of getting that one right. Also, and I see this a lot, sometimes I have students, take the exam on paper, circling their answers. And so I have to grade it by hand, and I have to read every answer on their page. And I see a lot of students circle the right answer and then change their mind, and you can see that it's been erased. And then they choose the wrong answer, And they say that your first choice is usually correct if you have an idea. I mean, if you're just Christmas treeing the test, you don't know. But if you have an idea, your first instinct is usually right. So keep that in mind. Unless you remember something, 5 minutes later, oh yeah, now I remember what it is, and then you can go back and change it. But usually, if you're unsure, your first instinct is righteous. Oh yeah, good. Scratch paper. The answer to that is NO, but there's room on the test, and you're going to be able to write on the test, so don't worry about that. There'll be spaces, in the margin, and, the bottom of the page, top of the page type thing. Colin.
Are we allowed to have our book bags and all that for the exam?
Well, yeah, I mean, you could put them under your chair and stuff, yeah. So, no, I mean, it's, unless you have x-ray vision. Do you have x-ray vision? Okay. Well, just don't use it during the test. Okay. All right, one more question. Galileo's new state of motion. Question 3 for today. We got a ton of questions. So hopefully everybody's here and clicking. And Galileo's new, now, you guys are working fast here. Ooh. The battle on the high seas. In the end, there can be only one. Ooh. Yes. The righteous answers are piling up. 10 seconds. 9, 8, 7, 6, 5, 4. Come on, you guys. 3, 2, 1, 0. I've got 99 votes, and more people came in after the first time I had 99 votes. Where are you guys? Don't you have your clicker? Don't forget to bring it. D is the correct option. And 53% of you, a majority, voted for D. Good. 47 of you got tripped up with B. That's a free fall position. And actually, that doesn't have anything to free fall doesn't have anything to do, not especially with his third state of motion. Constant velocity without a net force. So, All right, now we're going to do some more clicking in a few minutes, so don't put your clickers away. But here we go. Here's a little blurb about the homework. I want to show you this before we get deep into the lecture. In grtep.com, your first assignment is going to be running, and it's a review, a mini review for the exam. Now, we're going to have other stuff in the website, the textbook website, after exam 1. There's a chapter 3 mini review, but we're not going to be done with chapter 3 before exam 1. So I'll keep that in reserve for getting ready for exam 2, stuff like that. So before exam 1, this is your first grtep.com assignment. All right. Now, here's what it looks like. You go to the end of chapter 2. Okay? And, and there's some references down there, a couple, and what down here is the next button. All right? And you click the next button, go down there to the bottom. Now, there's another really tiny link that is like you need, like a microscope to see, but this is the easiest one. Okay, so go to the bottom of the chapter, hit the next button, and then it pops up to the mini review. All right, and then now right now it's not activated, but it will activate at I think it's 12:05 p.m. today. So, so you go get some lunch, and you can work on it. And I think I've got it set. Does it say how many attempts? I've got it set for several attempts. I might have made it 7 attempts. Oh, by the way, would anybody like another 1 or 2 attempts on homework 3 with the 11 and 12? So you think? All right. Okay, good. I'll do that. I'll do that this afternoon. So you'll have another couple shots at that for extra practice. And by the way, as I mentioned before, I'll re-mention it. If you really want to improve your confidence in handling equations, you might think, oh man, I suck so bad, at this stuff. I don't want you to think that way, because that's not going to be true in a few weeks. By the end of the semester, you're going to have, most of you are going to have a lot of confidence. And the way to do that is to study with me, study with Maria, study with a study partner. Okay, so if you, with another human being. And we'll talk after class, Axel. Try to get it squared away. Study with another human being. So look to the left. Look to the right. You see anybody over there? See a human being over there? And if you see anybody here that the same floor or whatever, try to make friends and, maybe study together. It really helps. And the other thing is discussions are quite helpful. All right. And that's if you're, if you got to blaze out of here and head back to Poinciana at 9:01 right after, or at 10:31 right after class, that's your schedule, you got to go. But then you can still use discussions as kind of a virtual study group. Now, inside web courses, here's the assignments page. Now, we've already, and you might not have noticed it unless you checked in about half an hour ago or later. Down here at the bottom, there's a separate category for homework in Great Rivers and the Chapter 2 mini review. And we'll have a bunch more down there. And the dates are set. And the way that's going to work, the data will not transfer automatically from Great Rivers into web courses. Now, some external websites can do that. Like over the summer, we used wileyplus.com for my physics book in summer B. And it downloaded into web courses after each due date passed, and download the score of the student. Okay, now Great Rivers doesn't do that. So what I will do is I will get a spreadsheet of your grades after, so like Tuesday night maybe, after the assignments due, and then I'll upload that myself into web courses. So and it'll show up in your grade book like everything else. But there won't be, you won't, like when you've got a homework assignment that starts in web courses, you can go back and look at all your different attempts, which is nice. But you can't do that in web courses for our Great Rivers homework. But I think you could go back and look at your attempts in Great Rivers. I'm not sure how that works. I'm kind of learning myself, so. All right. Now, any questions about that stuff? Okay, let's keep going. I want to go to the document cam and talk about hidden figures. So let me pause all right, let's go back to this question here. We're going to do an iClicker question. So hit your refresh key because you're going to do a short answer. Okay, you're going to be typing in letters, numbers if you want. And let me change this from multiple choice now to short answer. Okay, and you should hit the refresh key, and it starts at what, letter A? Is that what you got? Okay, here's your question. Type in a word or short phrase. I think it's 16 characters you can use that describes the motion of the object whose vertical velocity graph v subscript y is shown. Right now, there's no numbers in this, but you got a velocity graph. It's not like one that we used last time, though. Whoa! Listen to the clicks. Nice. Yeah, so think carefully about what you're going to send, and I think there's actually a space in there. And let me see what you guys are typing. And then hit the send key. I don't have any answers yet. When you're done typing in, hit the send key. It sounds like static electricity. Nice. Some of these are good. Nice. Uh-oh. Interesting. And you know what I'm going to do, you guys? I'm going to mark everybody correct on this one. So that you can freely, except it's kind of hard to keep up with you guys. Except I think there's some spelling. We should have a little spelling bee in here because you guys are blooping up your your spelling, but I guess that's all right. I've had some spelling. Although I'm a very good speller, I gotta admit that. And forget about Scrabble. I'm almost unstoppable at Scrabble. Ooh, some of these are cool. Yeah, so type in your word. And you can change it too if you want. Go use the back arrow key and the delete key and, change it. And I think the it's just tough to keep up with all these things. I'll wait till you guys finish. Okay, 1 minute. 1 more minute. And you know what you should do? Go ahead and make a sketch of this, because we're going to talk about this on document cam. And go ahead and write in the word or phrase that you sent. Okay? And we'll look at some of the answers before we go to the document cam. Right. Now, there's nothing in here, there's no numbers, but I did put in the bookkeeping bar on the right, for time T1, where the graph stops. But the time axis T, vertical velocity axis Vy. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Come on, one more answer. Okay. Let's take a look at some of these answers. Okay. Acceleration, increase. How can you tell the acceleration is increasing? We'll talk about that in a minute. All these are definitely accelerating because it's not flat. Acceleration up. Yeah. Accelerating. Accelerating. That's good. I get the idea. Acceleration. Everybody's thinking about acceleration. Accelerating. All right, I'll give you the points on that. Exponential. Yeah, okay. That's somebody that's been in calculus class. Exponential. No, it's not exponential, but I'll give you the points on that. Going slower? No. I'll give you the points on that, but no, it's not going slower. Gradual increase. Yeah, that's not bad. Increase speed. Yeah, definitely. Increasing speed means the slope is increasing. It's getting steeper, which, is definitely doing. Okay, I'll go back and look at these later. Keep your clickers out. Let me switch back to the YouTube. We're going to go back to that later, but now I want to do the document cam work. So this is where I should pause the YouTube. And a triangle, one on top of the other. But that's basically how they do it. So let's make some notes on what we just talked about. Velocity graphs. As I said, we already know constant velocity. Simple rectangle, the distance rectangle. Pretty cinchy, smooth acceleration like free fall, constant acceleration. Distance triangle. No, nothing too bodacious about that. We got that. And complex acceleration like a moonshot, or a submarine going through the briny deep. Just, work on trapezoids, and pixelate it, small delta t increments of time, and you can get it as precise as you need to. And so, up there in Virginia, they have a place called Wallops Island, and they still do small rocket shots from there for the NASA facility. To measure stuff. How small do I have to make my delta T's? So they sent up a couple small rockets there at Wallops Island and measure them, put the radar on it and everything. And they got tape recorders on board and, transmitting information, and, the accelerometer that you have inside your phone that prevents it from being ruined when you drop it on the ground on something hard, the accelerometer in your phone knows that it's falling, it shuts itself down. And that's how it protects itself from damage. I mean, to some extent. And they got accelerometers. They invented them for the NASA, accelerometers. So you got them on your phone now, but these guys had them on planes and stuff back in the 50s. So, but yeah, small delta T's, and then paste them all together and approximate the complex accelerated system, And basically, and the whole story of Hidden Figures is that prior to about 1950 something, they had, to do a lot of delta T's or a lot of delta X's, really small ones, they had to have a lot of computation. And before computers were widespread, NASA got some of the first computers, but before they became widely available, they had humans. Matter of fact, Katherine Johnson, there she is. Mighty Catherine. Long may she reign. She's still alive. Here she is a couple years ago getting the Medal of Freedom from President Obama up at the White House. And she did it. And of course, and I'm reading the book, Hidden Figures, and it's even better than the movie. So Margot Lee Shetterly. So go out and get that book. It's very inspiring. And it's interesting, the book goes all the way back to like the 1920s. And it's interesting because it also talks about this horrible history of segregation, of blacks and whites in Virginia and, all across the South. And how people like Katherine Johnson and Dorothy Vaughan and Mary Jackson, all the heroes from that movie, they came up through separate but equal, Jim Crow. Horrible. And Virginia was one of the worst places. So, question?
I was just wondering, did they not use integrals to get the area?
The question was, do they not use integrals? And that's a calculus question. And the answer is yes. And what they're doing is this is called numerical integration. That's how you do it. If you don't know all the equations of motion, or you can't look up the integral in the back of the book, you got to do it yourself numerically with a computer. I've done. We all of us physicists, we do it all the time. Yeah. So yeah, that's what it is. We're just using the trapezoid rule to do numerical integration. What's that? Yeah, that's right. You're doing Riemann sums. Well, Riemann sums are usually a little bit different, but it's a sum, And so, yeah. And the smaller your delta T's, in the limit of infinitesimal delta T, you get closer and closer and right onto the curve. So that's what you're doing. He's talking about calculus. If you've never had calculus, don't worry about it. But we have some calculus students in here all the time. So, accelerations, let's talk about this for a minute. What causes them? Now we know a free fall acceleration at the surface of the earth, good old 9.8 meters per second. Now that's a constant, or we consider it to be a constant. Now in reality, the acceleration due to gravity is a little bit different at the top of Mount Everest compared to the bottom of the Mariana Trench. All right, because it does change with distance from the center of the earth, the center of your gravitational object. But the variation is, a few dozen kilometers. And so the radius of the earth is about 6,400 kilometers. So this, from the top of Mount Everest down to the bottom of the deep blue sea is chicken feed, compared to the radius of the Earth. So there's not a whole lot of variation. So we rounded off at 9.8. But one of the ways that geologists find and prospect for minerals in the Earth is they have gravitometers. They fly a plane across a range of mountains or across a prairie that they're looking at, and they measure very small changes. 9.809 versus 9.810. Because if you're looking, for instance, if you're looking for uranium, and one of my high school instructors was a geologist, a retired geologist, and he prospected for uranium and for petroleum, and that's one of the ways they find it, by gravity. Okay, so you can detect small variations, but for most purposes, 9.8 is pretty good at the surface of the Earth. Now, some systems, you don't have a constant acceleration. Free fall, that's the one that Galileo chose, a good thing. And Connor, here's something else I'll just add to you. I've been saying, boy, it's so good that Galileo figured out free fall, because it's a constant acceleration. Basically, he figured out the triangles at the top of that trapezoid. He figured that out, all right? And because he figured that out, we can apply it now to all the changing accelerations, like that curve that we were just looking at. So now the space shuttle. Think about the space shuttle launching from Kennedy Space Center. All right. Now it starts out, you're looking at it, or looking at a film of it. You're not up there close, but you're looking at it, and it's they fire the engines, then they release it, and when the engines have got enough thrust, and it just starts rising like this, but eventually it starts really blazing. All right? But at the start, it's got a fairly small acceleration. Now that's kind of like the curve that we just had. Eventually, and one of my professors in grad school was a shuttle astronaut, and I asked him, how big does the acceleration get when you're launching in the space shuttle? He said, well, it's 3.3 Gs, which is nothing compared to the accelerations for a fighter aircraft. Those guys are going to take about 8 or 9 Gs on a really tight turn. But the space shuttle is a bigger object, not built for combat. So 3.3 Gs is what he said. That's at max acceleration. So that means it goes from a fairly low level of steepness, hardly steep at all, to about 3.3 Gs, quite a bit of steepness. All right? And so you may ask yourself, well, what is it about the space shuttle that leads to changes in its acceleration state? Because they can, if they have a radar gun or a radar on the space shuttle, they can basically, just like the police, they can figure out the speed, to a fare thee well using radar. Yeah. But that's plenty. If we had a spaceship, if we had an interstellar spaceship that could accelerate at 1 G for several years, we could easily get to other stars. But it's just, it's 1 G of acceleration for that long of a time is tough to do. And so you're thinking, oh, only 3.3 Gs. Yeah. But you've seen the space shuttle. It's enormous. And the flame coming out of the back end of that thing, it's enormous. Now, yeah, something like that. Yeah, so anyway, my last point here is that chapter 3 is the beginning of our answer. Now, before we get to chapter 3 concepts, Newton's 3 laws of motion, I want to show you this nifty table. And this is actual data from NASA for the STS-121 mission, which was 2006, right after, I think it was the first mission after the Columbia disaster. So let's take a look at some of the data. It's a PDF, and you can look it up yourself. Here's the first page of it. And here's the table of data. All right, now don't worry about copying down, but do look at this table with me, and let's look at some of the features of it. Now, what are the delta T's in this table? Yeah, we got ginormous delta T's here, 20 seconds. So this table is like a distillation of the real tables that they simulate and compute. So Katherine Johnson and her compatriots were doing thousands of additional lines, a lot more delta T's. You know, they might have been doing, for every 1 second, 1,000 delta T's. Delta T of 1,000th of a second, 0.001 a millisecond. You know, so this is a streamlined table, but it's legitimate data. So we got these huge. Now look up here. Now I said that the space shuttle, when it launches, it starts out kind of pokey. It's not even, it's not rising as fast as something falls straight to the ground. Right? It doesn't have a G worth. And you can look at here, the acceleration column, the fourth column there, 2.45. Now that's a good acceleration, but it's not G. All right? And of course they start at 0. All right? And then down here, the max acceleration to start with is here. And you may have heard of this critical point in the trajectory called max Q. Max Q for the shuttle is about 60 seconds up. And so a little bit after max Q, they start building up their acceleration a little bit more. Question? G is 9.8 meters per second squared. 3.3 times 9.8 meters per second squared. Yeah, so that's just a multiplier. So if you have when you're, like if you ever listen to somebody talking about fighter aircraft that making a high G turn, that means their centripetal acceleration going around the turn. We'll talk about that in a couple of weeks. Next week, maybe. No. Yeah, maybe next week. It's the acceleration into the center of the turn, the one that makes them black out and stuff. 8 or 9 G's, that's 8 times 9.8.
So it's gravity acting, 9 times harder on you than...
No, it's not gravity. This is a upward acceleration. So it's the rocket engines developing upward thrust. Earth's gravity, 9.8 is all you get. And it's downward. So this is counteracting that and then going past it and giving you all this upward acceleration from the rocket engines. Now, for a fighter plane, it's a dynamic. It's because they're curving, But now down here, looking down here, why is that one 520 seconds into the flight? Why is that acceleration so small now? No, not because they're letting go of the solid rocket boosters, but that's probably right about here. Yeah, no, but and that's going to happen. But I don't think that's what this is, because this is almost down to zip. What do you think in the back? Yeah, it's almost at orbit. Okay, because on orbit for the space shuttle, it's usually a constant speed, like 17,000 miles per hour or something like that. So that, but yeah, your instinct is right, Katie. The boosters let go right about here, I guess. All right, and then they throttle it up. Now, dynamic pressure, max Q starts at, go ahead and write this one down. And this is a formula, you can look it up on the internets. And since everything is true on the internet, yeah, right. Anyways, the dynamic pressure is fairly simple. 1/2 rho rho being the density of the air, times v squared times the square of the speed. All right, now that's the dynamic pressure. And if you think about it, I was asking you, why do accelerations change? The dynamic pressure against the launch vehicle, you know, the shuttle plus the boosters plus the liquid fuel tank, you know, you get a lot of air resistance, okay? It maximizes at about 60 seconds. Right? It starts at 0, and up there on orbit, it's back to 0 again. You know, they don't have any air resistance up there in orbit. There's no air. Okay, so it starts from 0, comes back to 0, so it hits maximum where rho and v squared together multiply out to the biggest number, and it's about 60 seconds of the flight. Now, what are the factors that change rho? The density of the air. How would the air be changed density? What do you think? Temperature, good. Anything else? Colin? Humidity, yeah. Altitude, all those things. And with altitude, the temperature and the humidity change. And that's why we get clouds at a certain elevation. You know, the heat, the warm air vapor rises to a certain elevation, then it's cold enough and low pressure enough to condense. And you form little droplets, micro droplets of liquid water, and they're so light that they're suspended in the currents of the air, and that's a cloud, a white fluffy cloud. The speed is also changing. Because the rho is changing, the speed is changing. So all these things are changing. And that's why the space shuttle and all those guys and one reason that they have a changing acceleration, right? Now, I want to, that's my last word about hidden figures, okay? And we'll probably refer to hidden figure concepts between now and, we're not done yet. Yes, we are. Well, here's where we're going to start on Thursday. Newton's 3 laws of motion. Maria, I already announced it. Do you want to say something? Let's give Maria 1 or 2 minutes here.
Hey everyone, I know I've seen some of your faces already, but those of you who don't know me, my name is Maria, and I'm your SI leader for this class. I know you guys have a test coming up next Tuesday, and I know Dr. already announced that we're not a review, but make sure that you will take advantage of the fact that today I have 2 sessions, and then on Monday I have 1 session for the review. So I know you had some questions about homework, so make sure that you come and speak at your points over material presentation.
You're going to be here in the next class, so if you want to ask her a question, just come up to the front. Okay, I'll see you guys on Thursday. Thanks, Maria.